let's do another example. So this time we're trying to graph f of x equals 3 times 2 to the x minus 5. So again, this is exponential, and the base is 2. So first, to graph, we need to find our parent function. Our parent function here is f of x equals 2 to the x power. That's the base and the power. This 3 that's in front is going to be a transformation. That's going to be a vertical stretch. So that is not part of the base. The base is only the part that has the exponent on it. So the base is 2, and then this is the exponent. So to graph a function using transformations, first we need points on our parent function. We're going to use -1, 0, and 1 for our x values. And then remember, we can plug those in to find our y values, or we can just use 1 over b, 1, and b. So in this case, I'm going to plug these in. If I plug in a -1 into my parent function, not my function I'm trying to graph, but my parent function, I'd have 2 to the -1 power. And remember, that's a fraction, 1 over 2. Or remember, that would be 1 over b. If I plug in a 0, 2 to the 0 power is 1. And if I plug in a 1, 2 to the 1 power is 2. We also have to include our asymptote. On the parent function, the asymptote is always the horizontal line, y equals 0. All right, so those are the points we're going to use for our original or parent function. Now let's do our transformations. So our first transformation here, do you guys hear my son? He's sitting here with me. My first transformation is this x minus 5. I would do that first because I'd need to do exponents first, but before I could do the exponents, I'd have to do the minus 5 that's with the x. Remember, when something's with the x, it actually does the opposite. This is going to make the graph shift to the right 5. And so the operation we have to do is we're going to add 5 to the x. Okay. Only to the x values, so add 5 to all the x values. So my new x values, this new x value, -1 plus 5 is 4. This one, 0 plus 5 is 5. And then third point, 1 plus 5 is 6. So my new x values are 4, 5, and 6. So far, my y values are the same. So 1/2, 1, and 2. Also, since this is affecting the y value, or sorry, since this is only affecting the x value, I don't do anything to the asymptote. The asymptote is y equals 0. So my asymptote is still y equals 0. Okay, now my next operation, we do need to do this in order to get the right points. In order of operation, we would multiply first before we subtract. So now I'm going to multiply by this 3. The 3 is not with the x, it's outside the x, so this is going to affect the y values. So this one, we're going to multiply y values by 3. Okay. So I'm going to multiply all the y values by 3. Now, since it's y values, I do have to do the asymptote as well, because that is a y equals. This is going to be affected by the y values. Okay, so now my x values are still 4, 5, and 6. My new y values right here, 1/2 times 3. Since we're going to be plotting this, if it's helpful for you, you can make that a decimal. We know 1/2 is 0.5. Or you can also do it on your calculator like this. You have to do 1 divided by 2 in parentheses and then times 3. So 1/2 times 3, I'm going to write it as a decimal. I'm just going to use 1.5. Okay, right here, 1 times 3 is 3. And right here, 2 times 3 is 6. Now on our asymptote, 0 times 3 is still 0. All right, so now I've multiplied all the y values by 3, so I've done that vertical stretch there. There's still one more operation. The last operation is this minus 5. Now this minus 5 is not with the x, so again, that's affecting the y. That's going to make it shift down 5. So for that one, we are going to subtract 5 from the y value. So I'm subtracting 5 from all the y values, including the asymptote, because that's affecting the y. My son is cranky today. Sorry, guys. Okay, so for this, my x values are still 4, 5, and 6. Now my new y values, right here, 1.5 minus 5. Again, you can use a calculator, and that gives us negative 3.5. Right here, 3 minus 5 is negative 2. And right here, 6 minus 5 is 1. But our asymptote, we have to subtract 5 as well. Right here, 0 minus 5 is negative 5. So we've done all our transformations. So these are my final points. And this is my final asymptote. You have to include your asymptote in order for our graph to look correct. So our asymptote is y equals negative 5. All right, so let's draw that in. I always start with drawing the asymptote first. So remember, that is a horizontal line. It's crossing the y-axis at negative 5. So right here. Okay, let's plot our other points. Almost done, buddy. 4. Negative 3.5 means I go right 4 and then down 3.5. So there's 3 and 0.5 would be right here. 5, negative 2 means I go right 5 and down 2. And then 6, 1 means I go right 6 and up 1. Now, once I have these 3 points, I can draw in my exponential growth function like that. Okay, so there's my graph here. So this one is an exponential growth function, but it's been shifted to the right 5. It's been vertically stretched by a factor of 3, and then it's also been shifted down 5. So that's what our graph looks like on that one. All right, we have one more example. This one, we've got f of x equals 1/3 to the x plus 2 power minus 3. This is still exponential because we still have a number as a base and then an exponent. This time, though, our base is a fraction. Our base is 1/3. So that means when I'm graphing this, my base, since it's a fraction, is going to be exponential decay. So this is going to be a decreasing function when we are done. So like before, we need to find a parent function. Our parent function here is f of x equals b to the x power, so 1/3 to the x power. And as we've been doing, we need to find 3 points. So I'm going to use -1, 0, and 1 as my x values. And then I plug these in. Now this one, since it's a fraction, it makes this point a little harder. If I do 1/3 to the -1 power, we can, if we figure this out, it's going to be 1 to the -1 over 3 to the -1. So remember, we raise both parts to that negative exponent, and both of these have negative exponents, so they're both going to jump the line and switch the sign. This one's going to jump to the bottom and become 1 to the +1. This one's going to jump to the top and become 3 to the +1. So this is just going to be 3 over 1, or just 3. So that one took a little while to figure out, but we got it now. All right, now this one, the rest are easier. If I plug in a 0, 1/3 to the 0 power is just 1. And if I plug in a 1, 1/3 to the 1 power is 1/3. And all exponential functions start with a horizontal asymptote at y equals 0. All right, so let's do our transformations here. Now, something like this, if you weren't sure about that point, about plugging in the -1, you can still use the calculator to help you with that. In parentheses, I would do 1/3 as my base, and then I'm doing that to the -1 power. Okay, and notice it gives me 3. So we could have also just done that with the calculator instead of trying to do that by hand. All right, let's look at our transformations here. I've got this +2 that's with the x, so I know that's affecting the x values. The +2 with the x is going to be making the graph shift to the left. And remember, with the x, we do the opposite operation. So since it's a +2, we're going to subtract 2 from the x. So let's subtract 2 from all our x values. So my new x values are -3, -2, and -1. Now, the only other operation I have is this one, this -3. So that one is not with the x, which means it's affecting the y values. Oh, going back to our asymptote here. This, since it only affected the x, the asymptote didn't change either. And so far, my y values are the same as well, 3, 1, and 1/3. Okay, now let's do the other operation. The -3 here is affecting the y values. So for that operation, we are going to subtract 3. Oh my goodness, you're okay. Here you go. We're almost done. Subtract 3 from the y values. So I'm subtracting 3 from all the y values. This time, I'm also including the asymptote because that is affecting the y values. So now, so far my x values are still -3, -2, and -1. My new y values, here 3 minus 3 is 0. Here 1 minus 3 is -2. And right here 1/3 minus 3. If you don't know what that is, just use a calculator and get a decimal approximation. We're not going to take the time to worry about learning how to subtract fractions. So notice I just did that on my calculator. 1/3 minus 3 is -2.67 if I round that. Or if we wanted to use fractions, that'd be -2 and 1/3. Or sorry, -2 and 2/3. I'm just going to put -2.67. That will be enough to graph. And now my asymptote, I also subtracted 3. So that's going to be y equals -3. So those are the operations that we are doing here. There was only 2 operations. So I am done with my transformations, and these are the points we're going to be graphing here. My asymptote is y equals -3. All right, so let's graph those. So y equals -3. Remember, that's a horizontal line. That's going to be crossing the y-axis at -3. So here's -3 on the y-axis. And I'm drawing that in as a horizontal line. So remember, exponential functions have horizontal asymptotes. Okay. Then let's plot these points. So -3, 0 is right here. -2, -2 is here. And then -1, -2.67 is a little bit more than the -2, so like right about here. Now notice when I draw this in, when I draw in my graph, this one ends up being exponential decay, which makes sense because our base was a fraction. So we knew our graph should be exponential decay. All right, so there is our graph there. So We are just using transformations like we did in Unit 2, and then we saw it again in Unit 3. And as I said, we're going to see it again in Unit 4 and in Unit 6 as well. So the difference here is our parent function is different. It's an exponential function, but we still find 3 points on our parent function, but we just have to include our asymptote as well. And then we do our transformations. All right, that's where we'll stop for today. And then we've got a little bit more of this section to finish up tomorrow.